Good day everyone, my name is Ribahenting Flores and this is my channel. Last video we discussed about spherical trigonometry, specifically the right spherical triangle. And for today we will discuss a certain topic that would serve as a continuation in spherical trigonometry, and it is all about the oblique spherical triangle. So the objectives of this video, the learners are now able to solve oblique spherical triangle. So what is oblique spherical triangle? It is one with no right spherical angle. So as we illustrate oblique spherical triangle, it would look like this. It is not straight line, instead it is curved. Is it because we are on spherical trigonometry? So there's no right spherical angles on oblique spherical triangle. Next, so this would be the 6 cases that we were dealing in, that we are expect to deal in solving oblique spherical triangle. So first is given the 3 sides. So it would look like this. Assume that it is side A, side B, and side C, given with that. Next, given with 3 angles. We have this oblique triangle and the angle which is A, B, and C. Next, given the 2 sides and the included angle. So when we say included angle, it would look like this. Given the 2 sides, so assume it is side A and side B, this would be the included angle C. Next, given 2 angles and included side, so it would look like this. Oblique angle, given the 2 angles A and B, so this would be the included side C. Next, given the 2 sides and an opposite angle of one of them, so it would look like we have this oblique triangle given 2 sides, which is the side A and side B and angle A. Next, given 2 angles and a side opposite one of them, so it would look like this, given with this oblique triangle given these 2 angles A and B. Our opposite side would either be A or B. So that would be the 6 cases that we are expected to deal in solving spherical oblique triangle. So this would be the law of sines. Sin A over sine A. Again, small letters denotes the sides, while the capital letters denotes the angles. Sine A over sine A equal sine B over sine B equal sine C over sine C. This law of sines would help us determining the value of a missing. It is either a side or an angle. Just for example, given a spherical triangle ABC, given a oblique spherical triangle ABC with A is equal to 80 degrees, B 70 degrees, and A, which is the 65 degrees in 6 cases, it would be the number 5 for having this given two sides and an angle which is opposite from one of the side, which is the angle A. Find B. As you remember, we have this law of sine, so just use it and then reform the formula about the sine A over sine B. Sine A over sine A is equal to sine B over sine B. Just reform those formula for us to find the exact value of our B. So we need to substitute the given values to our given formula. So we have this sine B is equal to sine 70 degrees, sine 65 degrees as our angle A, all over sine 80 degrees as the value of our side A. Just find the inverse of sine in our sine B for us to eliminate it and then find the exact value of our B. So we have B is equal to arc sine, or inverse of sine, parenthesis of our quantity of sine 70 degrees, sine 65 degrees, all over sine 80 degrees. And as we simplify, it would be equal to 59 degrees 52 minutes as the value of our B. Next is the law of cosines for sides. This would be the given formulas. First, cosine side A is equal to cosine side B cosine side C plus sine B sine C cosine angle A. Next is cosine side B. Cos is equal to cosine A is cosine C plus sine A sine C cosine capital letter B. Last would be cosine C is equal to cosine A cosine B plus sine A sine B cosine capital letter C, or angle C. For example, this example will help us understand those given formulas in finding the missing sides, since it is intended for the law of sines for sides. Example, when a oblique spherical triangle ABC with A is equal to 48 degrees, B is equal to 60 degrees, and C is equal to 55 degrees, find the angle A. So as you observe, it is the capital proper cases number 1 for having these 3 given sides here. So next step would be use the given formula, law of sines for sides. We have this given formula since we are finding the value of our B. For our A rather, just reform the formula which is the first formula, since we have this cosine C here. So again, we have this given, and then in solution, use the formula and then reform it. And by that, we are now able to substitute the given value. So just substitute to come up with cosine A is equal to cosine 48 degrees as the value of our side A, minus cosine 60 degrees as the value of our B, cosine 55 degrees as the value of our C, all over sine 60 degrees as the value again of our B, and sine 55 degrees is the value of our C. And by that, again, just always find the inverse of the trigonometric ratios in our goal to find. Like here we have this A, so we need to find the inverse of cosine A cosine in our A for us to eliminate it and then find the exact value of our A. So we came up with A is equal to r cos, or cosine inverse, quantity of cosine 48 degrees minus cosine 60 degrees, cosine 55 degrees, all over sine 60 degrees, sine 55 degrees, and it would be equal to 68 degrees 48 minutes as the value of our A. Just simple as that. Just simply as that. So next is we have this law of cosines intended for angles. So we have these given formulas. Cosine A is equal to cosine B, cosine C plus cosine sine B plus sine C cosine A. Cosine B is equal to cosine A, cosine C plus sine A sine C cosine B. Cosine C is equal to cosine A, cosine B plus cosine A sine B sine cosine C. As you observe here, it is similar to the law of cosines intended for sides. Just use capital letters in each and then substitute the last part as a small letter in our given law of sines for sides. Next would be the example in this given laws for us to apply it. Example: we have this given an oblique spherical triangle ABC with A which is equal to 84 degrees, angle B which is equal to 95 degrees, and side C which is equal to 100 degrees, and find angle C. So as you observe, it is the cases number 3 or 4 for having these two given angles and the included side. So we have this solution using the law of sine for angles, of course, and then just find the appropriate formula for us to find the value of our angle C. So we have this cosine C is equal to negative cosine A cosine B plus sine A sine B cosine C. Just reform the given formula for us to find the C. Next would be the substitution of our given value into our given formulas. We came up with cosine C is equal to negative cosine 84 degrees as the value of our angle A, cosine 95 degrees as the value of our angle B, cosine 84 degrees again as the value of our A, and then sine 95 degrees as the value of our B, cosine 100 degrees as the value of our side C. And again, just find the inverse of the cosine C for us to find the exact value of our C. So we came up with C is equal to R cos, or just the inverse cosine or cosine inverse quantity of negative 84 degrees cosine 95 degrees plus 84 degrees sine 95 degrees cosine 100 degrees, and that would be equal to 99 degrees 23 minutes as the value of our C. And that would be all for today's video.